Hello friends, good morning. In this video, we will just talk about AWS reserved recommendations. The below are the topics which would be covered as part of this video. Before getting further into this video, we need to know what is the purpose of RA recommendations, why Amazon has given this feature. So in order to know that, we would start from the billing. So every month or every time you see the billing, there would be a section of on-demand cost that would be always surprising us. And whenever we see the on-demand cost, then it means there is a lot of scope to reduce the cost by reserving instances. Yeah. So in order to reserve instances, we need to know the total number of instances or the type of instance that needs to be reserved. So how to arrive on that? We need to understand what is the current on-demand hours which we are consuming and what is the number of RA hours which we are using as part of that account, as well as if there is any RA hours coming from a different linked account. So if we understand this, then probably we can do some calculations coming up with the total number of EC2s and different instance types needed, which is not a straightforward task. So that's where this AWS has provided this feature or a recommendations. Whatever has been said before, all those has been taken into consideration, and just it comes up on the UI with the recommendations, the total number of EC2 as well as the type that we need to take into for the reserved instances. So that's what this RA is all about. If you log on to the AWS console and search in for AWS Cost Reporter, then you will be end up landing up on this screen. And we will be further looking these highlighted sections here. So on this recommendation screen, it gives us the total number of dollars that we can save annually if we could follow whatever has been recommended here. The savings percentage in terms of on demand, it could be 31%. And then the purchase recommendation. So all this data are pulled based on last 30 days of usage on the current account where I took the screenshot from. So that's what all this about. So this data varies account to account and based on your usage. And this usage can be varied either for based on last 60 days usage or based on last 7 days. You can just change as you wish. And the payment option can be changed as well. So if you're going to pay all upfront or a partial upfront or no upfront, based on that, this savings would get varied. As you know that how the payment option work. Yeah. So the no upfront would be a bit costlier than all upfront and partial upfront. So, and offering class, you have the standard and convertible. Normally, my preferred choice is convertible, but it depends upon how confident you are that particular instance type you are going to use it for that particular period of reservation. So if you are unsure that that particular instance type may get changed, then you can go in for convertible, because doing so, if you don't use that particular instance type or you are planning to change the instance family, then you can convert the instance type from one family to another family, whichever you are purchasing. So yeah. And then coming up here, so these are all the recommendations which has been provided. So what it recommends, buy one T2.2x large reserved instance, which could give me $100 monthly savings in comparison to on-demand instance, because currently this is running as on-demand instance. So that's why this has been pulled here just to show it as a recommendation to go in for reserving this particular instance. And the other data which you look to, which you are interested, is the region. So which region? It also gives us this region information. Also, what type of OS it is. It's a Linux PC or it's a Windows instance. And normally, if you observe the difference between the first and second, for Windows, there won't be the size flexible. But for the Linux, you will get this size flexibility option. Soon we will discuss what this size flexibility is all about. So again, on this particular row, you are recommended with 16T3.A.Nano reserved instance with the EU Ireland region. Again, this is based on past 30 days usage. So these are all the information that we get as part of this screen. So there are uh, few uh, properties or informations that needs to be considered when you are viewing the data on this screen, which we'll be further looking into. I would like to add one more information on this screen. That's this link here. So underneath each recommendation, you can find an corresponding associated usage based on which these recommendations has been arrived. So if I say like 16 T3 nano dot reserved instance, so there would be a link. On clicking that, it will take you another screen where it will show you the total number of on-demand hours as well as the RA hours and how this 16 T3.A.nano has been arrived. So just I will just show you on the later slide how clicking on this link, how taking to that screen, how that looks like. But for now, I will just stop here on this page. So we have seen on the previous slide that all the Linux instance are size flexible arrays, and we also remember that it was showing T3A.nano. Yeah. So in order to understand the size flexible arrays, I want to go through this slide and then further jump onto the size flexible arrays. So we all know, right, the different instance families. So we have this many instance families, and underneath each instance family, for instance, if I say general purpose, we have a lot of families under general purpose. We have the T3 family, T3A family, and goes on. And similarly on the compute optimized, we have C family, and then on the memory optimized, we have this R family. Okay, so there are different families. Underneath each family, we have different instance types. We have, if I take this T3 family, we have T3 nano, T3 micro, small, medium, and up to 2x large. So these are all the different instance types within a family. Okay, and if I take T3, and T3A is separate family, and it has its own instance type like this. And for example, if I go into the memory optimized R5 family, and these are all the instance types. So size flexible arrays always denoted on the lowest instance type in a family. For example, if I take this T3 family, the lowest instance type is T3 nano. And for T3A family, similarly T3A nano, where in case of R5 family, the lowest is R5 large. There is no R5 nano. That's the starting instance is the R5 large. Um, so any usage on this particular family, is it like T3x large or T3.2x large, or whether you use T3.large, no matter what Cost Explorer does, it will convert on that particular larger family into its smallest instance type. So that's how, if you remember on the previous slide, the usage was shown in T3A.nano. Yeah, but actual instance type used might be T3A.large or T3A.x large. So what a Cost Explorer does, it just does the converting this T3.A.large and T3A.x large into its smallest instance type, T3A.nano in this case, and it will recommend us how many instances do we need to reserve, treating this T3A.nano as the instance type. Okay, so how this conversion is made, something we will be seeing on the next slide. So yeah. So this is the table which will be used in converting those T3A.x large or T3A.2x large running hours into T3A.nano, and it will be represented that many number of instance has to be reserved. So for instance, if we assume that C4.8x large, that's the instance which has been reserved. So with one C4.8x large, you can apply the cost for its different instance types within its family. For example, if I have one C4.8x large and I am using one C4.8x large, which is running on demand, so the cost will be equal. I no need to pay any on demand. There won't be any on demand cost. So similarly, if I'm running two C4.4x large on my account as on demand, then I no need to pay, there won't be. So this is equal to 2C4. So one C4.8x large is equal to 2C4.4x large. So this is totally based on the normalization factor. So for example, if I take C4.8x large, the normalization factor is 64. If I take C4.4x large, then factor is 32. So 64 divided by 32, which is 2. So 2 4x large is equal to 1 8x large. As simple as that. So that's the conversion factor. So that is normalization table helps in normalizing one instance type into another instance type within its same family. Okay. So just if we treat this C4 large, C4 large, the normalization factor is 4. So 64 divided by 4, which is 16. And 16 C4 large is equal to 1 C4.8x large. Okay. I can run one C4.8x large on my account or 16 C4.large. No matter what, there won't be any on-demand cost. Everything would be considered as RA. Everything will come under the reserved. So there won't be any cost involved. So this how this all works. This is called as the size flexible RA. So how Amazon, while doing the calculation, it will do the calculation with its flexibility in size. Okay. So I think hopefully you would have understood that example. Similarly, if you have one T2 medium, which is equal to 2 T2 dot small, as well as if I have, okay, in this case I had a larger instance which I could apply for a smaller instance. Vice versa also possible, like if I have a one T2 medium, okay, and then I have one T2 large which is running on my account. With this T2 medium, because one T2 medium, actually, if you look at the normalization factor here, for large it is 4, and T2 medium it is just 2. So 4 by 2 is 2. So 2 T2 medium is equal to 1 uh, 1 T2 dot large. So T2 medium, here we have only one T2 medium, then only 50% of cost would be covered. The rest of the 50% would be treated as RA hours. Okay. I think that's all. All this has been covered here. Yeah. Okay, we'll move on to the next slide. Even from the easy to calculator, you can just prove it's the same cost. For R5.large, the normalization factor is 4, and for R5.2x large, the normalization factor is 16. So 16 by 4, which is 4. So 4 R5.large is equivalent to 1 R5.2x large. So if you put it onto the calculator, it would just come around the same cost. So this is the slide which we will get when we navigate the link that we have seen on the recommendation screen, the view easy to usage. So on clicking that link, we will be taken to this screen. So what this screen is not that legible, but I will just take the data and put it onto table on the next slide. But what I would like to uh, want you to view about, if you look into this on-demand column, there are two rows, on-demand dollars and on-demand normalized hours. So on the right, the instance type is C5.2x large and C5.4x large. So these are all the two different instance types on the C5 family, which was running on that particular account. And it was recommending in C5 large, and then navigating that C5 large recommendation, it is just taking us to this screen. So on this screen, whatever we see is completely the on-demand normalized hours. So it means whatever the time it has run, the instance run for C5.2x large and then C5.4x large, that will be normalized, and the cumulative hours will be displayed here. So all these are like cumulative hours of the C5 family on the individual days, and finally this will be summed up to get the total normalized hours and the respective on-demand cost. So that's how AWS cost reporter works on the normalized hours and normalized units rather than the individual families. For example, here on the on-demand cost, we have this somewhere around 81K normalized hours, and that would come around $1,742. So how this is been calculated? So the total hours is like 81K normalized hours. So divided by 4, this is the normalization factor of the C5 large family, and that would give you this many normalized hours. And for each hour, the cost is 0.085 for the C5 large, and the total cost is 1,742. That's something it's been arrived here. Okay, and I will just put it onto another table, all this data, just to give you more detailed explanation of what is normalized hours and what is the normalized unit and how the normalized cost is calculated. Yeah, sorry, not the normalized cost, how the cost is calculated based on the normalized hours. Okay, this is the table with some sample data. Let's say as continuation of the previous slide, let's assume that C5.2x large and C5.4x large are currently running on my account, which is on demand. Okay, so those first two rows are the ones on demand, and the last row is the one which will come up on the recommendation. So I would like to just split this into two parts here. So till this one, and then the rest of this. So the first part will be how to arrive the number of units that is in C5 large, because this is the size flexible RI on this C5 family. C5 large is the smallest one. So based on the running instance, how AWS calculate the number of C5 large to be reserved. Okay, so in this example, let's say C5.2x large, there are two units which is running, let's say for a month. Okay, both 2x large and C4x large. The number of units are 2, and the normalization factor for 2x is 16 and 4x is 32. So this is the normal. And what will be the normalized units? It will be multiplied by this unit and then the factor, which will be 32. And here in this case, it would be 64. So this will be the normalized unit. And for C5 large, if you want to convert the C5.2x and C5.4x large into C5.large, then the normalization factor for this C5 large would be C4. So if you sum up these two, which would come around 96 normalization units, and then dividing by 4, which will give you the 24 units which is needed, or which will be recommended for you to reserve. So we no need to do it individually for C5.4x large and 2x large. Instead, if you reserve C5.large 24 instance, that would serve the purpose of these two instance, whatever it's running, which will be covered. So it would be covering all the on-demand hours of this. Just we need to reserve C5.large 24. The second part which is used is the normalized hours. So these normalized hours are used for the billing. Okay, so as a continuation of this one, so C5.2x large and C5.4x large. So let's say this is running for a continuously for 1 month. So for 1 month there will be 24 into 30, which is equivalent to 720 hours. So since 2 units are running, let's say 1440 hours running hours on 2x large and 1440 running hours for 4x large. Okay, and what would be the normalized hours? So this is the running hours. You need to just keep a look on this one, because in a lot of cases on the cost reporter you can see the running hours as well, but all the cost everything will be on the normalized hours. So normalized hours is nothing but the running hours into the number of normalization units. So in this case 1440 into 32 and 64, which would comes on 46K and 92K respectively. So if you sum up these two, it would come around 138K. And the normalization factor for C5 is divided by 4, which would come around 35,560. Sorry, 34,560 into the on-demand cost for C5 large per hour. Okay, so that would come around 1,486. Even if you do it on the easy to calculator, just to make sure our calculations are right. So here in this case, we have the C5.2x large, which is 2 in number, and C5.4x large, again 2 in number. If you just see the cumulative cost of this would come somewhere around 1,493, which would be the cost of 24 C5 dot large. So that's where we arrived. This 24 C5 dot large, that would be the number of units recommended on the size flexible units recommended on the C5 instance C5 dot large, which will be the lowest instance type in the family. And the cost 1,000 we have it somewhat closer, 1,486, and here it comes 1,493. So that's how the cost would be calculated on the AWS Cost Explorer. So this is a quick summary on what we have seen so far. So if you look into the Cost Explorer, it considers the size flexible arrays. So all the recommendations will be on the size flexible arrays. So size flexible arrays will help us to maximize our savings. So all the calculations will be made on the normalized units within the family. So as in the example we have seen, if the instance type is C5.4x or 2x, it will be converted into the lowest instance type in that family. And Cost Explorer uses the smallest normalization factor to represent the instance type that it recommends. So as I just on the previous example, I split it into two. One part is just to find the number of instance type needed, and the other one is to how to calculate the cost. So for calculating the cost, we will use the normalization units in order to identify the normalized hours. And for the arriving on the number of instance, we use the normalization factor. And using that, you have seen like how we arrived the total number of instance type on which is on the lowermost in the family is required. Yeah, and you can just purchase the RI on the regional level, the size flexible RIs, but it can be applied on any availability zone. So it's across the zone you can apply it. So if you see at this example, so this is what the AWS Cost Explorer gives us. So you can see this is the max array. So any families in the any instance types in the family, irrespective of its size, it will be converted into the size flexible arrays. So that's what it meant. And we will see about the limitations. If you remember on the first slide on the recommendations, you didn't see the size flexible arrays, which is coming next to the Windows instance. So it was empty. Only for the Linux instance, we have seen the size flexible array. So there are some limitations for the size flexible arrays. So you cannot do the size flexible RI if the reserved instance are with a dedicated tenancy, or if you are doing a purchase on specific availability zone, again you cannot you cannot utilize the size flexible RIs. And then for Windows and Windows Server with SQL standard or whatever it is. If it's a Windows instance, then again you will not be able to use you will not leverage the size flexible arrays, because on the recommendation when you are reserving, you have to go in for the exact size rather than the size flexible arrays. You cannot go in for the the lowest in the instance family. And again for G4 instance, we cannot use the size flexible array. So these are all the limitations. The recommendations are based on this following three important points. The Cost Explorer recommendations are not forecasting. It will not follow a trend. It depicts or reflects the data based on the last 30 days usage. So it assumes the next 30 days usage would be of same, and it recommends the instance type and its family, the total number of instance and its instance type. And the second point, all the data it provides are purely based on the usage on that particular account which you are viewing. Okay, and it includes any RAs that are already reserved on that particular account, or if that account uses any of the reserved hours from another linked account, then that also been already taken into account, and only based on the on-demand hours the recommendations are made. Okay, so it take into account both the RAs which has been reserved on that account, as well as the RAs which could have been shared from some other linked account. So in case of consolidated billing, you will be having a parent account with a lot of linked accounts. If any one linked account is not completely utilizing the RIs, and if the same RIs are used, if the same family is used on the other RI on the other linked account, then the cost will be used on the other family, on the other account. And the third point, the recommendations will not assume the same RI which has been shared from a linked account. um, it will not be considering it will not assume the same number of instance hours would be coming up from a linked account for the subsequent month as well. Yeah, so those are the three important points which we need to take into account. Will be a couple of reports which comes default on the Cost Explorer. One is the utilization report, another one will be the coverage report. What you can get out of the utilization report is whatever the reservations you have made, how much you are utilizing it. So that's what we can infer from this report. So this gives us the opportunity um, to understand what are all the reserved instance types that could be converted to another family in case of convertible instance, because that was those instance types are least used than expected. No, there is no 100% utilization on those instance types. So that's what we can get from this utilization report. So as an example, this is how the graph will look like. So here it says whatever I have reserved, we are using 85% of the reserved ones. But if you see, there is a small gap. That gap is because of this T2 medium, M5 large, and T2 medium again. So all these are not fully utilized. So here in the T2 medium, we are utilizing only 13%. The used hours are 546, but the unused hours are 3822. So what we can do is, like, we can just mark all this T2 medium, large, and this one, whatever the instance which is not completely utilized. When we say completely, when we say it's not completely utilized, based on the unused hours. So you can mark all those instances, and then on the next report, coverage report, you can see what are all the instance which is using on-demand hours, and you can convert this instance to the other instance type which is using on-demand. It could be of a different family, but we can do this only if in case of convertible instance. So that's why I prefer the convertible instances. So if you, on that utilization report, if you just expand this drop down, you will get more details on that particular instance type. And here in case you can see the unused hours cost is $155. So unnecessarily we are paying $155 without much using this particular instance type. RA coverage. So this report gives us the total RA coverage against the total running hours. If you look at this RA coverage, only 40% of 40% of hours has been covered under the RA, but rest 60% are still treated as on demand. And the table below gives us more information on that. If you see, just for an example, T3A.large, the first row here is using the on-demand hours. Okay, so on the RA utilization, we know some of the instance which is not fully utilized. And on this report, we know what are all the instance types which is using on-demand hours. So what we can do is just we can pick one of the instance types, treating assuming that what it was convertible, and we can convert from the unused instance to the family which is using on-demand here. So by that way, we can reduce the cost. So if you go on to the reservation and after this two report, you just identifying that some of the instance can be converted, then you have to move into this section on the EC2 reserved instance, select that particular instance, and you can just exchange the reserved instance. Like moving from one family to other family, then you can go on to the exchange reserved instance. Or there are other options here. You can just modify the reserved instance. So within the family, if we have to convert from one instance to another uh, instance type, then you can use the modify reserved instance. Or if you have to renew the reserved instance, then you can go in for this option, renewed reserved instance. So this is how the modified reserved instance looks like on selecting the modified reserved. So M5 X large, it would be 8 units. So you can convert any type within the M5 family as long as the number of units does not go beyond 8. So if it is exceeding 8, this will be turned into red. But if it is lower, again you will not be allowed to add. So you have to keep this 8. Let's say like if you're going on to m5.large, then you can to select two m5.large, then that would you get 8, and once it is green, then you will be able to add. And this is the exchange reserved instance screen. So here in case you have the m5.large, you are selecting that reserved instance, and then you can just select in this drop down another instance family, and you can just click on the find offering, and you can just convert from one family to another family. So on the recommendations, you will also have another option, another report which says the right sizing. So this report gives you the information of any of the instance type which is not utilized up to its capacity. For example, we are reserving some C5 dot 8x large or 6x 4x large, but there is no much memory usage or CPU usage. So it will be calculated and then it will be recommended. You can on that same family you can just downsize onto a smaller type. In that way we can reduce the cost as well. So that's how this report would be helpful. So here it says the list of instances that could be downsized, and then the potential savings, and then the percentage. Yeah. So here in this case, if you just go into view, it will just suggest you. You will see on the next slide. So here in this case, it's a T3A dot large where it suggests you can go in for T3A dot medium. Okay. It does all this based on the utilization, disk memory, etc. And this is one more hint. If you want to move the reservations from one account to other account, yes, very well you can do it as long as those are linked accounts. Why we might need to do this? Because if you have to do some efficient handling of the reservations, it will be best to have all the reservations within that account itself, rather than sharing from a different account. For instance, you might be on one account, you might have migrated onto a different account. On those occasions, it's better to move the reservations onto the new account because all the reservations will be first applied to the account on which the purchasing is made, and only any spillover then will be applied to the linked account. So always it's best to move or just to have reservations on the usage account itself. So other one, if we have to move the reservations, that's something we cannot do it ourselves. So we need to contact the AWS support team where they will be providing a template, just filling up and submitting the template. They would do it for us. But the key thing is like this should be submitted from the payer account or not from the linked account. I would like to run through this three scenarios to better illustrate how the RAs will be applied. So in this scenario, we have account A where these are all the different instances which is running on demand. And yeah, so and we have this reserved instance for by m3.large, which is reserved at the region availability zone level. Okay, if it is something reserved on the availability zone level, then it could be applied only on the same availability zone. It can't be applied or used on the other availability zones. So on the other hand, we have a 4 by m4.large. Okay, let's see like how the array will be applied. So here this is 4 by 3 m large. This is also 4 by m3 large. So there won't be any on demand. So the arrays will be used for this on demand. So which is good, and this will be applied as both are the same availability zone. And the second example, there are 2 by m4.x large. Here it's 4 by m4.large. Based on the normalization factor, 2 m4 large is equivalent to 1 m4.x large. So all the 4 m4.large will be used for 2 m4.x large. Okay, and here if you look at this is at the region level. So if you are doing the reservation at the region level, you can apply it on the any availability zone level. So no issues here. Okay, and there is one C4 dot large, but here you have C4 one C4 dot X large. As per the normalization factor, 2 C4 large is equivalent to 1 C4 dot X large, but here we have only 1 C4 dot large. So what happens? 50% would be counted as on demand, reserved, and the rest of the 50% will be on demand. So this scenario will be insisting this couple of points. First one is like always the RA will be applied within the purchasing account itself, and then any excess qualifying usage will be applied to the linked account. And the second point, the RAs will be applied from smallest to the largest instance type within the family. So we will just see the example on this. So here we have two accounts, account A, which will where we are purchasing the reserved instances, and then we have this account B, where some on demands are running. So here you can see on the on demand 2 m4.x large, and then running in availability zone A, and then one m4.2x large in US East 1B. And on account B, again, we have 2 m4.x large. So here also it's 2 4 m4.x large, here also m4.x large, and here it's 1 m4.2x large. Okay, so what we have reserved is 4 by m4.x large. So the question here is, since there is m4.x large here as well as m4.x large here, where it will be first applied. So this is the first point. Always the RIs will be applied on the purchasing account. So in this case, out of this 4 by m4.x large, 2 will be applied here. Okay, fine. And then you have this 1 by m4.2x large. So 2 m4x large, which is remaining here, that will be applied for the 1 m4.2x large. So then it goes here. Okay, and then this will be running on demand only. There won't be any RI hours for this. So this will be treated as on demand. And here we have 2 by c4.x large. Okay, and then this will be covering up 2 c4.x large here, and this 1 c4.2x large will be running on demand. So this 2 c4.x large won't be applied here, as the second point says, always it will be smaller to the family, and then it will move up the ladder in the same family. So this will be applied here but not here, so this will be treated as a on demand. That's all this example is about. So this one, we have three accounts, account A, account B, and account C. Here we will see this example will explain the scenario of purchasing a zonal reserved instance in a linked account. Okay, so we are not purchasing at the region level, but we are doing it on the zonal level, but in a linked account. So for instance, if you see on account A, we have reserved one m4.xlodge. Okay. And on account C, we have one m4.xlodge which has been reserved. The only difference is on this account A, this is purchased at the region level, but on the account C, it is purchased at the availability zone level. Okay, same instance are available on two different accounts which has been reserved. So there is coming to on demand, there is one m4.xlodge which is running on availability zone US East 1A, and on account B, it's running on US East 1B. Okay, so how the RI will be applied? So there will be very smart, the AWS will apply the RIs. So always the zonal reserved instance. So as you know, if it is reserved on a zone, then it will be applied only to that particular zone. So what happens in this case, on account A, you have the instance which is running on US East 1A, and you have a equivalent reserved instance which is on account C, because in account C nothing else is running. There is no on-demand instance running. So this is potentially can be shared on the other linked account. So what AWS will do will just smartly find this info, and then this will be applied for the first on-demand here. And then what it does, it just look on the account B on-demand here, which is running on US East 1B, and there is a one M4X lodge which has been already reserved in account A, and this will be applied. So this will be applied here for this on-demand. So what is special about this? Why it's very smart? I said because if we just switch the order, let's say this particular reserved instance, which is at the region level, as applied to this at first. Okay, so this is good. One m4.xlodge, which will be applied for one m4.xlodge. But on the account B, which is running on demand on US East 1B, okay, we have the account C reserved instance which is on 1A. So whatever the reserved instance available here, this cannot be applied here, as the reserved instance applied on the zone level, it should be eligible only for the same zone. So that's why I use the word smart. AWS does this for this internally. All this just for for informative purpose, but we don't need to do anything. All this will be behind the screens. AWS does the calculation for us, but it's good to know how things work. Okay, thank you so much for listening to me. We will just see in another video. Take care. Bye bye. Thank you. See you sooner.